the galaxy. In a dark cloud, there are particles of gas and dust milling around. And by chance, a little knot forms. It has enhanced gravity. It pulls in some more particles, puts up the mass, puts up the gravity, pulls in more particles. And over a period of 10 million years, a knot grows and grows and grows. The temperature in the middle rises and rises and rises until it reaches 10 million degrees Kelvin and nuclear reactions start. Let's assume, so as we're not here all night, that this is one of these massive stars, 20 times the mass of the Sun. And the star devastates itself. The material of the star, enhanced in carbon, nitrogen, oxygen, calcium, silicon, sulfur, floats off into space. And some of it floats over here, to where there is another of these dark clouds. And that material joins this dark cloud, and when there happens to be a little knot of particles that gets together, enhanced gravity pulls in more, new star forms, grows and grows and grows, temperature reaches 10 million degrees. Let's also assume that this is a big star. Big stars aren't that common, but I need to focus on them. And the material from this star floats out into space. This material contains the carbon, nitrogen, oxygen fabricated in the star, plus the carbon, nitrogen, oxygen that came from that exploding star. So if you like, it's doubly enhanced. And this material floats out into space, and some of it floats over here to another dark cloud in the galaxy, where a star called the Sun is forming. In just the same way. Little knot of particles, enhanced gravity, material gets pulled in, star grows and grows and grows. And ultimately, nuclear reactions start. It's been doing that for 5 billion years. But not all the material got taken up in the star. There's a certain amount of material still hanging around outside. And with time, this material forms itself into a disk, a bit like a giant version of Saturn's rings. And in the disk, material goes around but bumps into each other. And sometimes lumps stick together. Of course, sometimes lumps get broken apart. But gradually, 8 planets form, plus the asteroids, which would have been a planet if Jupiter's gravity had not prevented it. And we're on one of the inner planets. But at least to begin with, all the planets were made of the same stuff as the Sun. Because the inner planets are quite close to the Sun has boiled off some of the more volatile materials, like hydrogen and helium. So we tend to be the stuff that doesn't boil off easily, the rocky silicates and things like that. But basically, our Earth is made of the same stuff as the Sun, which is the product of 2 of those explosive cycles. Our Sun is a 3rd generation star. And because we're 3rd generation, we contain some material from that first explosion, plus material from the second explosion, and the Sun is now busy making more chemical elements. But the stuff we were formed from had been in 2 stellar cycles previously. Our Sun is a late-forming star, a Johnny-come-lately, long after the galaxy had done the bulk of its star formation. But we needed to be a late star, because that way we had enough of the carbon, the calcium, the iron, and so on. I've talked in particular, and perhaps given the impression that it's 2 specific explosions. On average, it's 2 explosions, and it's not just 2 in particular. It's explosions that could be anywhere in the Milky Way. We've incorporated material that's been through 2 explosions somewhere in the galaxy.